Today, we are going to talk about introduction to transaction processing. Okay, so first of all, let's see what is a transaction. Transaction is a logical unit. It's a logical unit of database processing. It includes one or more operations. It can be read operation, can be write operation. Okay. And we can see the transaction consists of automatic unit work. Okay, for a transaction, either all those operations, either they complete all of them or not at all. Okay, not at all. So basically, transaction requires for transaction, we can see two things, either nothing or all. Okay, so that's the logical transaction. So we want to finish all the database operation in one transaction, either finish nothing or finish all of them. Okay, let's use a balance transfer example to show. So when we go to a bank, we want to transfer, do a balance transfer, we can wrap the transfer operation into one transaction. So we can start transaction. And then the next thing we want to do is we want to withdraw from saving account with $100. And then can do deposit to checking account with $100. So then that's end of transaction. So this whole transaction here, we can see we have two operations, withdraw and deposit. So if you go to a bank, eventually, most likely they will tell you, okay, yes, this transaction done successfully, right? So that's good, okay. And what happened is, what can happen is we finished the withdrawal operation. So $100 done, okay, taken away from your account. But before we be able to do the deposit operation, okay, we have system failure, say power loss. And because of whatever failure we have, then you have 100 from your saving account already, but don't have the 100 in your checking account because the failure is between these two operations. And I feel none of you actually have this, right? It's just because we do have this transaction control. Nobody wants to see that situation. So if we wrap the whole thing as one transaction, then either all of them done or nothing at all. Means you either have this 100 still in your saving account that's before you start transaction, same thing as you didn't even ever start transaction, okay? Or finish everything at the end, you have the transfer successfully. So that's why we see the whole thing here, this whole thing from here to here, together we wrap it into a transaction. It's a logical unit. Either it complete in it entirely or not done at all. Okay, all right, so let's move on. So there are four most important properties of transactions. That's the ACID properties. The first one, automaticity. This one talk about transaction is one unit of processing. So this is exactly as what I gave the example in the previous slides. Either we can perform all the operation or nothing at all. So again, this is the all or nothing, right? All or nothing here. Okay. So the next property is consistency, the C property. This one talk about if we run a transaction, then the transaction need to take the database from one consistent state to another. So if we have consistent state, the database state is T1, then we run the transaction. After that, then we produce a state, say D2 here. So D1, if it's a consistent state, after we finish transaction T, then D2 should also be a consistent state. what is consistent then? So consistent state means the database satisfy the constraints specified in the schema. Where did we learn constraint? In relational model chapter, right? We learn what are the constraint, like the key constraint, domain constraint, all those things. So we can define different constraints, and the database is consistent if it satisfies those constraints. This is the consistency. So next is isolation. This is the one talk about we can have more than one transaction running at the same time. So we can have, say, 5 transactions running interleavely. Okay, they do interleaving concurrency. However, the result should be same as should be isolated. So as if it is being executed in an isolation from other transaction. So in other words, when we run one transaction, it should not interfere with other transactions. How can this be done? We'll soon talk about this. This is something called concurrency control. So by concurrency control, we can achieve the isolation property of a transaction. Then let's see the durability. Okay, when a transaction changes the database and the change are committed. So committed, this one is a special things in transaction. Okay, when we finish all the operations successfully, we'll commit the transaction. Once the transaction commit, then the changes made by the transaction, say just like what we have in here, right? So basically we change the transfer the money, change the withdrawal from saving and deposit to into checking. This kind of change in database should be in the disk permanently. It should not be lost because of subsequent failure. So this is the one when we do bank transfer, right? So when the bank tell you, yes, the transfer successfully, you expect to use the $100 in your checking account to do something, right? And you are not happy if they told you, okay, it's done, transfer successfully, but you don't have the money in your checking account because there are subsequent failure in their system. Okay? So this is the durability, and this is the one can be the durability and permanency. This one we can do this, achieve this property by recovery. So there's a technique called the recovery. Okay, so let's see some important information of a transaction. What we want to know about transaction? First of all, we want to know the beginning of a transaction. We want to know when the transaction start, right? Okay, and then I want to see what are the read or write operation on the database that is a part of the transaction. Read is taking read item from the database, retrieve information, and write is we modify the data and write things back to the disk. So that's the write operation. And we also have the end transaction here. And that's mean all the read-write operation ended successfully. So when we talk about the write operation, okay, so this is the one, a lot of things in the transaction, the write operation only means the value of, say, if we write X, and the X, the value is 100, and this is the value when we perform things in the transaction, it does not mean the write operation 100 will update the database item in the disk immediately. And when this operation actually change the database item, this depends on different logging protocol. And that's something we'll talk a little bit further, little more details at the end of today's class. Okay, so then let's see the commit transaction. Basically, at the end of transaction, if all the operations successful, okay, we can do commit. This one means all the changes, right? after we commit the transaction, then all the changes run by the transaction can be safely loaded to the database. Basically, you can think about commit, it's successful, right? Okay, and then for rollback, also called abort, this is the other case. So we can have a transaction unsuccessful. And in that case, we need to move to the nothing. So this is, if we think about what we talked, this is all, so we finish all of them. This is one should be nothing. We need to roll back, right, to the state that nothing happened. Okay, so now let's see how can we handle system failure, right? So we can have system failure such like a power loss. So if there's no power because memory is not persistent, so everything in the memory, like the bank transfer example, right? So if the calculation is within memory, then power loss, we don't have anything. What can we do? So the way to handle this is using a log. So the log can keep track of the transaction operations, especially the one change database values. In other words, the write operation is the most important one, but the log keep the read-write operations. Okay, and what a log can be done is the log initially, it is in the memory, okay? So there's no magic. Still, log need to be read and write in memory because we cannot read and write the disk directly. So log is in the memory. However, the log is pushed to the disk periodically. So this is the one, again, according to the logging protocol, that there are certain time that we force the writing of log to the disk. So at a certain time, the content in the memory need to be write to the disk. So a portion of the log, whatever portion we push to the disk, right, at the given time, depends on how many records we have at that time, will be on the disk. So when we have system failure here, we can take the log from the disk and the recovery from the log entries in the disk portion. And also, periodically, we back up the log to other storage. So if there's a disk failure, okay, the disk that contains the log fails, then we still can have another place to find the log. Okay, so this is a typical way to keep the log record. So you can see we have start transaction. So we need to keep which transaction we started. And this part is a transaction ID. So for example, can be transaction T1, can be transaction T3, and each transaction has a unique ID here. And the next operation is write operation. So if we have read 2 and 3, we have read and write operation, we need to know that. So if this is a transaction T1, right? So transaction ID T1, and that will be T1 and T1 and T1 here. So we can read item T1 and we read X. We also can have write item, and 2 and 3, they can repeating. Okay, can be X, can be Y, can be any database item. In a transaction, we can have many read and write operation. For the write operation, not only we want to say we are going to do something on X, also we want to have the old value and new value. So this X is the database items, like can be a record, can be a table, okay, can be anything we work on for the transaction. And so for X, for example, it can be attribute also, and we want to keep the old value and new value here. For some of the logging protocol, we may not necessarily keep both, okay? So for example, we may only need to keep the new value without the old value, okay? Okay, so this is the operations. Then at the end, either it's a commit transaction or abort transaction. This is the one successful, right? So this is a successful one. And the abort means this is not successful. We have something wrong in the middle, so we can abort a transaction. So that's the log record you can see. And we can have many transactions running at the same time. So it is not surprising to see in the middle of that, I do have start transaction, so T2 here, okay? And we can have other operation on T2. So we can have the transaction interleaving here. Okay, so in other words, when we talk about concurrency, that's the interleaving concurrency, concurrently execution, interleaving, okay. So we know the concurrent execution can be parallel or interleaving. So when we do transaction, it's actually the interleaving one. All right, so let me get rid of this. Okay, so now let's see database recovery. So why we need to consider recovery? This is the main reason is, we can have something wrong in the middle of a transaction, right? And we want to restore the database to the most recent consistent state. And that's basically what we talked before. That's either all means we finish all the operation, or nothing. Nothing at all means nothing have been done for this transaction. We go back to the very beginning, okay? And the main purpose is to preserve the ACID property. So in other words, preserve the A property and D property to achieve the C property here. Okay, so in our example, bank transfer, right? So if part of a transaction fail, for example, withdraw successful, but before we do deposit, then we have problem, okay? So when we have this, if a part of a transaction fail, for example, this other part of fail, then the account balance should not be changed. So you still have the $100 in your saving account. So that's recovery, basically want to make sure either everything finished or nothing at all, because the transaction is one logical unit. Okay, so let's see the recovery technique. Mainly, no matter which technique we use, we need to use log to help us. So when there's a system error, we want to go to the log and take the content in the log and to see what to do. How to design the log, when to write the log to the disk from the memory, and that depends on the two different techniques. One is deferred update technique. In this technique, we do not physically update the database on the disk until after transaction reach commit point. So in other words, before a transaction reaches commit point, we cannot change the database. So that's the one, if we go here, so when we finish the transaction, right, so we can commit. Before we do that, this operation, they are calculation in memory. We are not be able to change the database saving account or checking account on the disk at all in the deferred update technique. Where is it? Okay, so in this deferred, we cannot change it, okay? And the next one is immediate update technique. In this one, okay, the database may be updated by operation for transaction before the transaction reaches commit point. So before the transaction finish, we can change the database item on the disk already. Okay, so that's the different two techniques, regulations. We do have more details on them in 174. Okay, we have more details and examples, those things in 174. Okay, so basically, according to the two techniques, they are two logging protocol. One is the protocol related to deferred update. The other is according to the immediate update. So in this deferred update, we have some logging that handle redo operation. Okay, for the immediate update, we have the logging the log allow us to sometimes redo, sometimes undo, depends on different situation here. So the redo operation taking the new value of the database that get changed, right? So say if we have 100 plus 5 equal to 105 here. So initial value is 100 and our calculation is plus 5 and then result is 105. Then 100 is the old value, 105 is the new value. So when we do redo, we don't actually really redo, okay? We don't do plus 5 again. Instead, we take the new value, 105. And for redo, we take the old value, right? So we don't use 105 minus 5. Instead, we take the old value here. So that's also the reason you see the log we have here. Here, so some of the logging protocol keep both old and new to make it possible, okay? All right, so that's for recovery. And another thing important in transaction is isolation, right? We talk about isolation at the beginning. So even we have many transactions running concurrently, they should not interfere with each other. How can we make sure they are not, let me move on to, okay, here. So move to here. So say transaction should appear as if it is being run in isolation and should not interfere with by other transaction. How can we do that, right? And that's related to the technique called concurrency control. So we can have transaction executed concurrently, no problem, but we need to control them. So in other words, we cannot let them run. We cannot let them run whatever they want. Okay, we want to control them. And the concept related to that is schedule and the serializable schedule. And that's basically, we want to have something called a serializable. And in order to be serializable, they will equivalent the concurrent execution for transaction can equivalent to some serial schedule, means sequential execution. Okay, they are concurrent but have the same good result as a sequential operation. So that are actually hard to say at this point because we do have a set of definition to define the equivalent and I mean code of good property, those things. So so this one takes some time to explain. Again, we'll have this one in 174. Okay, we'll talk about more detail there. In concurrency control techniques, we'll in 174 again, we'll see how can we control them, right? What is the technique? We use two-phase locking to make sure we can do concurrency control. So that's the, again, topic we'll cover in the higher class if you are interested. So at this point, I finish the introduction to transaction.